Have you ever been sitting in a plane, this giant metal tube, just rocketing down a runway, and thought to yourself, how on earth is this actually possible? Well, I promise you, it's not magic, it's physics. And today, we're going to learn the language of flight. We're going to break down the basic rules that get these incredible machines off the ground.
So let's just start with that one big question. How does an airplane with the mass of like 10 adult elephants actually lift off into the sky? The answer isn't just one thing. It's this really cool combination of a few key ideas. And to get there, we have to build our understanding from the ground up, literally, starting with the plane just sitting there, not even moving yet.
Right. So before we can even think about making this thing move, we need to get a handle on what the airplane is. We got to wrap our heads around some fundamental concepts: mass, weight, and of course that constant pull of gravity that's always trying to keep it on the ground. Okay, first up, mass. You can think of mass as simply the amount of stuff an object is made of. For our airplane, that means everything: the metal frame, the giant engines, all the seats, the luggage in the hold, the fuel in the wings, all of it. And that amount of stuff, well, it's constant. We measure it in kilograms. And we're talking about a lot of stuff. Your average medium-sized jet has a mass of about 60,000 kilograms. To put that in perspective, that's like 40 cars all welded together. Just try to keep that number in your head, because that is the sheer amount of matter we need to get airborne.
But here's the thing. Mass isn't what's holding the plane down. The reason all that stuff feels heavy is because of weight. See, weight is the force that gravity exerts on all that mass. It's the Earth's constant downward pull on our 60,000 kilogram plane. And because it's a force, we measure it in newtons.
And this little chart really nails the difference. Think about it. Your mass, the amount of you, is exactly the same whether you're standing on Earth or you're on the moon. But your weight would be totally different, right? You'd be way lighter on the moon because there's less gravity. This is so important for flying because the goal of an airplane is to generate an upward force that's stronger than its weight, not its mass. And here's a cool part. All of that incredible weight, this massive downward force, acts as if it's all concentrated on one single crucial point. We call it the center of gravity. Every single move a plane makes, pitching its nose up, rolling its wings, or turning left and right, is just a rotation around this one point. That's why it's so incredibly important where they put the cargo and the passengers.
All right, so we've got our plane sitting still. We know what it is. Now, let's make it move. This next part is all about the action, the forces that actually create movement, the work those forces do, and the power you need to do it all fast enough for takeoff.
So the driver of all movement is something called force. It's really just a fancy word for a push or a pull. And in aviation, we're always dealing with four main forces. You've got weight pulling down, lift pushing up, drag pulling backward, and the one we care about right now, thrust, which pushes the plane forward.
Now, just having a force isn't quite enough. To do what a physicist calls work, you have to actually use that force to move something over a distance. So the engines create a force, that's thrust, and as that thrust pushes the plane down the runway, boom, it's doing work.
And this is such a perfect example of that. Just picture it. The plane is at the end of the runway. The engines are screaming at full power, ready to go, but the pilot has the brakes slammed on. The engines are creating a huge amount of force, but because the plane isn't moving, the amount of work being done is zero. Nothing. No distance, no work. Simple as that.
Okay, so if work is about getting something to move, then power is all about how fast you can get it moving. It's the rate of doing work. An engine's power rating tells you how quickly it can do the job of moving that plane down the runway. More power means you get up to takeoff speed a whole lot faster.
So we know what the plane is, and we know what it takes to get it going. But once it is moving, it has something really, really important. It has a secret ingredient that is absolutely essential for flight. It has energy. And we're talking about a specific kind of energy here, kinetic energy. That's the energy of motion. And how much it has depends on two things: its mass and, this is the crucial part, the square of its speed. Let me say that again. Not just its speed times itself. This little bit of math changes absolutely everything.
So just look at this. At 100 knots, the air hitting the plane has a certain amount of energy. But watch what happens when you just double the speed to 200 knots. You'd think the energy would double, right? Nope, it quadruples. It goes up by 4 times. This relationship is exactly why speed is king in aviation. The energy you need to fly goes up like a rocket as you go faster.
Okay, so we've got mass, we've got force, and we've got energy.
Now let's tie it all together with the universal rulebook for how things move, Sir Isaac Newton's 3 laws. And these aren't just some dusty old theories from a textbook. These are the practical, unbreakable rules that every single flight has to follow.
So the first law is basically the law of laziness or inertia. It just says that things want to keep doing what they're already doing. Our 60,000-kilogram plane sitting on the runway really does not want to start moving. It takes an enormous external force, thrust, to overcome that inertia. And once it's flying, it doesn't want to stop or turn either. This second law is the one that really connects the dots. It tells us that to get our massive plane accelerating down that runway, we need a really big force. And how fast it accelerates depends on 2 things: how much thrust the engines are making and how heavy the plane is. It's why a lighter plane with huge engines has that amazing super short takeoff run.
And finally, Newton's third law. This is where thrust actually comes from. A jet engine works by sucking in a ton of air and throwing it out the back as hard as it can. That's the action, and the equal and opposite reaction is the engine and the whole airplane connected to it getting shoved forward. It's that simple and that powerful.
So let's just do a super quick review of everything we've built up. Mass is the stuff, weight is the pull from gravity. Work means you have to move something, and power is how fast you can do it. Remember, doubling your speed quadruples your kinetic energy. And the whole thing is governed by Newton's laws, the absolute bedrock of what makes flight possible.
So I'll just leave you with this. The next time you're on a plane and you feel that incredible force pushing you back into your seat as the engines roar, you're not just feeling speed, you're feeling physics. You are literally feeling Newton's second law in action as massive force overcomes the huge inertia from his first law. That's the language of flight,